So, all right, how would you like to go about this? We can go back and forth if you want, or just see where our conversation carries us.
So, sounds fine to me. I've taught optics for 10 years, but
Yeah.
never really taught about mirages. And
Okay.
I have to say, I don't understand them very well.
Well, that's really interesting. I'd love for us to maybe, maybe touch on that a little bit. So, um, how would you, because you just made that statement, how would you differentiate what your field of optics is and how it would relate to Mirage? What are some similarities? What are some differences? Like even areas where they are incongruent, where you can't make a one-to-one correlation. Let's talk about that a little bit.
Well, the things that we teach in optics is lenses and telescopes and diffraction, using optics for a spectroscopy through a diffraction grating, to identify elements, to even do astronomy work in optics, because you can measure the Doppler shift of distant galaxies and different stars. So physical optics is really where we were. And mirages didn't come into that very much. I was really spent more time on things like sundogs and the green flash, and things like that.
Yeah.
Yeah. But mirages, in terms of the hot rod effect, are pretty straightforward. But these mirages, which involve multiple layers of the atmosphere at different temperatures and trying to anticipate what the image would look like, that's pretty tough for me.
Well, I find it fascinating. I'm very interested in that.
Yeah, I know that. I appreciate the fact that you've put your pictures up, because, like I say, you got to see it. Because even the revised version of the islands that I sent to you, it's all hypothetical because I've never seen anything like that.
Okay, sure. Yeah, well, I guess it would be hypothetical for you. For me, it would be standard because I've captured images like that, which is why I was able to look at those photographs on the website and say, okay, wait a minute, because it actually took me a while to notice that disconnect that I found. I was looking at this like, why does this not look right to me? I'm looking at this, I'm like, I know that there's something that's off in here. And that's where I was able to look at it and say, oh, I see what happened there. That it is actually, this is missing in the reproduction of the image. And there was another thing that I saw even after the modification that you sent me. There was another aspect of it that I thought we could bring up when we were talking, and maybe we can just do that right now.
What about me sharing the screen with that particular diagram?
Sure. Okay.
Now, the question I had is, even once I made this change, there's got to be a transition between that sky and the water, and where to put that transition, is not clear to me.
Oh, I see.
And what the nature of the transition would be. Now, I'm really depicting a mirage of all the way to those little treetops going downward.
Right.
And so at least you would have that part of the mirage, I would think. And that if I'm going to put in a water interface there, it'll be below those treetops going downward, I would think.
Yeah. And as a matter of fact, that was the point that I was going to bring up with the file that you sent me. So if you can imagine bringing in the water, you could actually bring the water in at any level so that it could actually cover up the treetop itself because of the, I guess I would call it the depth of the mirage.
So if you did that, you would be saying that you were getting a light from the water surface that obscures the mirage of the treetops. Then would you be saying that? And And
Um,
that would involve what you're calling a uh, proximal looming,
proximate looming.
proximate looming of of the water surface.
Yeah, yeah. So it's interesting that I've often thought that there's not always just one event or one phenomenon happening in an event. You could have an inferior mirage with proximate looming, but you wouldn't have looming and proximate looming. So in looming, you're only going to get looming, but with an inferior mirage, you can possibly have looming, but also possibly not have looming. It just depends on what's happening. But so if you look at the text that you've got in that bottom diagram, the visual image with vanishing line and inferior mirage, if you were to put in blue water up to that point, that would be perfectly okay. You could even raise that water up to the bottom of the words geometric horizon so that you're cutting off the treetops, right? So you can have a different level of the x-axis in your field of view depending on the intensity of the mirage, if that makes any sense.
Yeah, but the thing is that the thing is thinking about it is you're talking about something which is the whole island is maybe past the horizon. Of course, it could be. So,
Well, let's go with what you just said there. So if we go up to the top image with the full color image with the warmer water,
yeah,
so if we take that for granted that the water and the island is our line of sight, so that's the horizon. Okay.
well, what about the curvature of the Earth, which puts the horizon out
Yeah,
of
yeah, I
5
know
kilometers?
yes, that's a perfectly reasonable response that I think that we should hold in our back pocket or table that to the side for just a moment. What I want to suggest in my experience, when I can show you different photographs of the same observation with the same focal length, and there are different fields of view. Okay, so in one, I've got a much broader field of view where I can see a wider image, but then it looks like in the other one that I've actually zoomed in because I've lost that depth.
Yeah,
But see,
yeah,
the
that's
thing,
really fascinating to me. And I think you've done a great thing there by maintaining a specific setting on your camera, so that you're actually, from the camera's point of view, you're taking the same frame all the time. But
right,
the fact that you see it differently means there's optical phenomena going on out there.
right. So then, what I want to suggest, this was actually the second item that I thought about, which would have to be, I suppose, whenever, because this is your website and whatnot. But your question about the horizon, I'm going to try to see if I can say it this way. Um, the top image with the warmer water, if we're going to take that for granted that that's the horizon, the vanishing line, if you want to carry that vanishing line down in your mind, because it's not in the second image, but if you draw that vanishing line across that second image, what we need to understand, in my opinion, is that the amount of land under that vanishing line and the horizon is still there physically, even though we can't see it.
Yeah, agreed.
So what that means is that sometimes, because the size of the island, let's take it for granted in the middle there, sometimes that island will seem like it's farther away from us or closer to us, again, depending on the intensity of the phenomenon. So it would look like, again, if this top image that you had were an actual photograph that someone took, so that's your control. This is what it normally looks like when there's no intense refraction going on. We can see the shoreline and this, that, or the other. And then the image below, you might have a kaleidoscopic effect that isn't the result of your camera, but the result of the phenomenon itself. And to me, that keeps me going because on the Chesapeake Bay, I've got 5 different locations that are stationary that I know I can take a shot at, and I'm at the same location. My camera's at the same height, and the only variable that's changing is the condition of the medium.
That's great. That's a great way to do the experiment, I think. And
Yeah.
so
Yeah.
I can learn a lot from that, because I'm having to deal with. I'm not sure how carefully Robert Greener thought about all of this. I did interact with him yesterday.
Yeah.
Because I asked him about something I'll show you a little later.
Okay. Sure.
But he's a neat guy.
Well, I really enjoyed his presentation. I don't know if you saw that I put that up on my website, but
yes,
the science
one
bag.
used long burner, multi-burner thing to heat the air.
Right.
Yeah, that's the kind of thing I'm used to seeing from him at the American Association of Physics Teachers meeting. And I go back to probably late 70s with him in those meetings.
Okay.
Because he's kind of a contemporary of mine. I guess he started in university teaching like 4 years before I did. Okay. So I started in university teaching in '68.
Wow. Yeah. And so a lot of your background then is just astronomical refraction and optics?
Well, optics has not really been a field of research for me. It just what I got into in teaching. My research is in molecular spectroscopy of molecular spectra. And then, a secondary specialty is acoustics, because I taught a musical acoustics course for 45 years, developed that course. So optics, I did teach for 10 years as a, junior level undergraduate course, but we did very little with atmospheric optics in that.
Okay. All right. Is there any place you want to go right now with this, or you want
to? I'm trying to think about what I would do to make this is a hypothetical diagram, but I was trying to think about what to make it more realistic. So to bring up a blue water line, it's clear, and my inclination was to bring it up short of the tips of those trees. So you're sort of assuming that you're seeing water, but then you're seeing the refraction of the sky. But the only thing that bothers me about that is that anything that I've seen over water was definitely not a uniform straight line. You had waves and ripples, and you had differences in intensity of the light that you see. Mm-hmm. And so this is far too uniform, but I don't know how to make it ununiform.
Well, again, you could almost alternate. Let's say, for instance, it would be really interesting. Okay, so just to offer my photography as a suggestion, right? I could provide you with at least a mile, 3 miles, and 5.85 miles. Once you get beyond that, the resolution of the eye and even the lens is I've got a 9 mile shot and a 12 mile shot, but the ability to see the shoreline with any clarity is lost. But at the 5.85 and the 3 miles, I can show you a straight line of sight to the shoreline. So just for instance, I could provide you with a control image for your colder air, warmer air. And you could put in your vanishing line and all of the text that you want. And then I could provide you with hundreds of slides for your bottom image to just show one, show another, show another, show another. Because I've gone out for the past 3 years all of the 12 months, and I can show you different degrees of the inferior mirage, because we're talking about inferior mirages with these images in particular. And what I mean by that is that you will see not only the depth of the mirage change, but you'll also see the size of the observation itself change.
Yeah,
So
that's still a little mysterious to me, how you effectively get a magnification effect.
I know, yeah. I mean, I have seen some comments in Andrew Thomas Young about magnification, and other articles that I've tried to follow up on, where they do talk about magnification. But I understand your comment. And all I can say is that I can provide observations that where I have not moved my setup, and the only explanation for the different depth of field is the medium.
Yep. Well, that's great. I mean, I guess that's a way to do science, is to have a control, and so you have a good control there, and so that surprised me to see that difference in effective magnification. But the thing that I'm thinking is that all of those changes have to take place just because of different contour of temperature in the air. I don't see any other working mechanism in there.
Well, how would you do that with the profile?
I'm thinking that if you're looking in a vertical line, it has to depend on the temperature of the air at all of those vertical points, a temperature contour. And that's the other, well, maybe just sweep down and show you what I'm talking about as far as these contours. Because what I was talking to Greenler about was, how in the world do you get this kind of variation? Because this comes from a 1799
Yeah,
article.
yeah,
They'd see upside down sailing ships and upside down sailing ships separate. Now, all of those basically have to come from just the temperature profile of the air. And so Greenler's take on that is to show a temperature profile with height, and then show the kinds of bending that would take place for different rays at different heights, but with a pointing in different direction. That, like ray number 5 is going up into a warmer area, so it's getting slightly higher speed on the top of the ray.
Can I stop you just real quick? I just have a question. So because the graph on the top is Greenler, and your modification is the one below it?
No, all of this is Greenler. That's what I was asking him about last night, was could I use them, because I basically drew these from one of his diagrams in Rainbows, Halos, and Glories.
So you took what he's done in a book and just reproduced it here.
Yeah.
Okay, so
I redrew it because I was just seeing the lines on a white page, and so I could understand it better if I put in the color profile.
I hear it.
So I could visualize the temperature difference.
Right.
And so then he's saying that the curves that he has in that top diagram are what allows him to explain the mirage. And so he's giving you at the bottom, in the bottom diagram, how that kind of behavior could produce the observed image. That is, ray number 5 goes from the top flag, and it managed to be bent down to the observer. But when the observer looks, he's looking up at a higher angle, so he sees that flag at a higher altitude. But ray number 3 comes from almost the same point, but when it's bent down, it's coming off at a different angle, and coming bent down, it gives to the bottom flag. And then ray number 2 gives him the flag that's associated with that bottom refracted image,
which would be what I would call sinking or proximate lumen.
Yeah. Okay, well, so this is the way he does it, and so he was very kind. He says you can reproduce anything in that book if you give me credit for it. So
Uh-huh.
that's
Okay.
good to get that resource.
Yeah.
It's a really neat book. Uh,
Yeah, I'll
and
have to look at that, at getting that. I guess my question is, how is the science done to, I guess, translate what happens? So when we're looking at the image of the ship, CB, we're looking at a first person. That's a self-centered orientation, right?
well, that's
I mean, that's where we're looking straight ahead, and that's what we see in our
yeah,
field of view,
straight ahead at the ship.
right?
Yeah,
So the image that you have on the bottom, though, is taking it to an orthographic.
yeah. Well, yeah, it is a little awkward there because your viewpoint over there is the right of that diagram, and
Right.
the thing I reproduced on the right is
Yeah, I don't have
in
a
that
problem.
direction.
I think that's a part of, I think that's a part of the dynamic. But I guess my question is, I would like to see the science, if it's out there, to show how they understand that this is what a ray is doing. You know, the
Yeah,
five and the five and the four. I mean, that's a
it
pretty drastic change between the five and the four. And I would imagine that as we're looking at something that's in front of us, we can't see any rays doing these things.
exactly.
And
You know,
so,
this is very puzzling to me. I mean, I can see that you can go to his set of rays that he proposes on that bottom diagram and say, okay, it gets you to those key points, the 5, 4, 3, 2, and 1 on the image. But if I just had that set of curves at the top, there's no way I could get to that bottom one. I don't know how to transfer
oh, I
from.
see. Yeah, yeah, yeah.
No, the thing at the top is reasonably straightforward, that if you had ray number 5, if you had a ray starting that was slanted upward into a warmer region, it would be bent back down. But the amount of change is minuscule. It's like 1.00025 to 1.00027. I mean,
Sure,
the change in index refraction is
sure.
really tiny.
But it almost has a more drastic effect.
Well, you got a long distance. I guess that's the only way I could make sense of it, is that it's a very tiny bending, but you're bending over a large distance if you're looking at something that's 5 kilometers away.
Mm-hmm. Yeah, I guess. Do you know, again, if there's any resource to where they've been able to break these things down on the field? Because I don't think that I could reproduce um, something like this by just my standing where I stand as an observer, taking the photographs that I do. I don't think that I could, for myself, if I were in this field and if I were doing research in this, um, I don't know how I would be able to tell you what rays are doing. I guess that's my problem. I'm trying to understand how they know.
I'm not, I don't know.
Yeah.
And see, that was my big thing. I've scratched my head over this diagram for quite a while.
Yeah. Well, like I said, it's almost, I mean, it's intriguing. You know, it's like some people, like I suppose you and I, would find this very interesting and spend quite a lot of time looking at it, and someone else would be like, there's no way I'm going to spend my time looking at this. It has no interest to me whatsoever. But like you said, you've spent quite an amount of time looking at this and trying to figure this out. One of the things, again, as I've looked at Andrew Thomas Young, there are so many times when he makes certain statements that I wish that there was a link where he would take me to the source for his statement, because I don't I want to find out how he, what he's basing that statement on.
Well, he certainly has put in a lot of work there.
Oh, no doubt. Yeah, no doubt.
Now,
Absolutely.
the only place the time that I have spent with him in the past, this is the first time I've looked at his refraction material.
Okay.
But I have spent a good bit of time on his green flash material because he's really one of the best experts on green flashes.
What do you find intriguing about the green flash?
Well, I've tried for years to find one, but the only one I've seen was in the North Georgia mountains.
Oh,
I,
you saw one?
yeah,
Okay.
but I've tried many times, down Key West and down in the Keys where you got the nice sunset over the ocean, and I'd watch it through or video it through and not get any hint of the green flash.
I have one capture of it in the past 3 years.
Well, it's tough. I mean, it has to be right.
Yeah.
The conditions just have to be just right.
Yeah. Yeah.
And I was really surprised the time I saw it because I was taking video of a sunset over a fall mountain uh, range, just a mountain range. So,
Okay.
and it lasted about a second. And so I was videoing it, and it only got 2 frames
Mhm.
on the video camera.
Yeah. Yeah. I also do observations on the California coast off of Ventura on the Channel Islands. And one of the sunsets there, I had happened to be filming in time lapse. And the very last frame, I don't know, 10 minutes. So every 10 seconds, it would take a shot. The very last frame was a green flash. Nothing before, and it was the last frame, and then nothing, nothing after. And that last frame was green. I was just ecstatic.
Yeah. Yeah.
But that's the only time I've caught one. And I had a friend of mine show a video on his YouTube channel last week. I was watching it, and as it got closer, I thought, you know what? I think this is going to be a green flash video, and it was. He had a green flash in it. So yeah.
Yeah.
I love
Yeah.
it. I love it. It's almost like watching a there are novels or books that are written fictions where you can choose to go to a different ending, right?
Yeah.
So, all of these observations, they all start out almost the same, but you never know how they're going to end. It's just something different every single time.
Yeah.
So it's really fascinating.
Well, for this particular diagram, the top part of the diagram makes sense to me. Maybe not quantitatively, but qualitatively, that if you're heading upward at a steeper angle, like number 4, into a warmer region, you're going to get more bending with 4 than 5, because 5 is going up at a more shallow angle, so it's not going to have as much change in the index of refraction. So it seems to me that a set of curves up there is consistent, self-consistent, but I don't have any good way. If I saw that alone, there's no way I could get to the bottom one, because
Yeah. So how did you get to the bottom one then? Or was that just Greenler?
it's just a copy of Greenler's
Okay.
take on it,
Yeah.
and he didn't say how he got there. I guess I could ask him.
Well, I would commission you to do that if you could. See if you could nose around and find out what what lens he's using over his glasses to look out and see those rays that I can't see.
Yeah.
Right?
I don't know. I just think he was trying to find a way to identify those key points of the image. And,
Yeah. Yeah.
and then
Yeah.
you could have to say, okay, that ray 5 would do it. It would take a ray from the top and down at your position, it would give you an image that looked quite a bit higher than that.
Mm-hmm.
Because that final ray that you're looking up is up at a higher angle, and it's going to go above that position on the ship.
Yeah.
you know, Young does a lot of calculation, and he does those diagrams of that triangular object out there, but I just can't follow it all.
What is it that you find difficult to follow?
Well, he goes to a greater distance and then sees the top of that image rise higher. He's getting some, I suppose you'd call that looming or towering. And that's okay. It's going to be look like it's higher. And then he makes it narrower. And I guess that perhaps just the fact that it's more distant, it's possible. But then at the bottom, he actually curves the bottom inward at the bottom of his triangular, what started out as a triangular object.
Mm-hmm.
And I don't understand how that inward curving comes about.
Well, I think I'm following what you're saying. Is there a way? I think I have his link already pulled up. I can share my screen if you want to switch that over.
Okay, I'll stop my share.
So here we have the image at 1 kilometer, and
Yep.
we have the horizon behind the image. Okay.
Okay.
So here we have he's moved back 1 more kilometer, and this is just the way that I'll say it. That not only adds distance, but it also adds density to the medium. Does that make sense? So the reason why you have this bending of the object here toward the horizon is refraction, right?
Okay, but
so if you think about going back to a 1 kilometer, we've just got straight edges. If we're just going to be crude about it, just straight edges, boom, boom. This is a triangle,
yep.
Straight edges all around. But here we've got an arc right at the end, and the only thing that could be creating that would be the conditions of the medium.
Yeah.
Okay, so that's at 2 kilometers. Now at 3 kilometers, we have a more intense curve or arcing of the image, I suppose, right? And then at the very bottom, you've got a very severe. This is an inferior mirage here. This one here is also an inferior mirage, but it's less intense. This one here is the beginning of the inferior mirage. So with each one, you've got one kilometer, there's no inferior mirage. He moves back at 2 kilometers, it just begins. It's so slight. 3 kilometers here, we can tell that this is not a normal shape for this object. We know that it should be triangular. And then the 4 kilometers is, almost symmetrical. This is kind of like what we were talking about with the web page, right? So imagine that we had a fully inverted image here so that we could see the tip inverted underneath, right?
Yeah.
So that would require that the mirage would actually extend closer to our proximity, which would then lower the water level, so to speak. Does that make sense?
Yeah, I'm beginning to get it. I was bothered by the fact that the change was in the horizontal plane, and I was thinking about the variations that we're seeing as mainly vertical plane variations. So that was part of.
Well, okay. So can you differentiate for me what you mean by that horizontal plane and vertical plane, just so that I understand you?
Well, just horizontal like the surface of the water, and the vertical as you see it, but the change in the temperature is in the vertical plane. And that change in the sound of the light speed in the vertical plane is what produces the refraction.
Okay.
Because the ships didn't seem to show that, at least that's Greenler's version, doesn't show any horizontal dimension changes.
I think that's possible because the observers at that point were not changing their distance. They were staying there, and the ship was then going just simply laterally across their field of view. So the ship wasn't going farther away. The ship wasn't getting closer. They were wherever they were. They're not changing any of their distance. So they're not going to have that kind of alternating effect. So what's interesting about this, if I can make it clear, is I can show you these kinds of effects in my observations, except I'm not moving. So in these diagrams that Andrew Thomas Young has produced, he's the one who's the variable. He's the variable, right?
Yeah.
So it's on the same day, same temperature, same meteorological profile, except he's moving himself farther and farther back. The thing that I'm trying to say is that I'm stationary, but I can show you these kinds of effects with all of my observations, and I'm not the one that's changing. It's the medium.
Mm-hmm. Yeah. Yeah. I'm a great fan of photography, that's for sure, because you're seeing what is. You're not just thinking about concepts, theoretical concepts.
Is there anything else you want to follow up with this in terms of?
No, I guess not. It's just I'm still bothered by that.
Well, here's another thing. Let me say this.
More.
Let me say this as well. One of the things that I think is a shortcoming in Andrew's diagrams is that it, for the most part, the top of the target seems to stay symmetrical, but he's moving back 1 kilometer each time. So that's going to have to follow the lines of perspective.
Yeah, the horizontal perspective. It getting narrower, I don't have any problem with.
And so it's not a fault of his. And like you said before with Greenler, I can't remember what the context was, but to a certain extent, we were saying he's not talking about this. I don't fault him for that. We all have those, I guess, myopic blinders on that we were looking at something and this is what we noticed and we're just talking about that. Someone else who comes along and says, well, have you looked at it from this angle? I think that some of the things that you and I are talking about are looking at it from another angle, which is why I'm thankful that I was able to get a hold of you and suggest the point that I was making about the sky being miraged, right?
Yep.
No fault of yours, no fault of Greenler. But that was the one thing that I was looking at that image and thinking there's something wrong. What is not looking, why does that not look right to me? And then when the light clicked, I was like, that's it. We forgot to mirror the sky as well. So the one thing that I would say about this image is that not only do we have the effect toward the horizon, but we also have to take into consideration how the vertical part of the target is going to change as well. Not only angularly, but optically, because as you increase your distance, you're also increasing that profile. You're doubling it, so to speak. Like if you're at a 1 kilometer here, and then you go to 2 kilometers, you've just doubled your profile, right? It's almost like moving a magnifying glass closer or farther away. Does that make sense?
Yeah, I'm gonna still have to scratch my head about these.
Well, yeah, I'm not hoping for answers to everything right now, unless you have lottery numbers for me. But yeah.
Well, I do appreciate the level of work he's put into it, and
yeah, absolutely, no doubt. one thing that I did work on, if you give me a moment to try to see if I can pull it up. Okay, so this is all his information, but all I've done is overlaid my what I call the red roof house. So this red roof house is 5.85 miles away, and while the water level is right at the bottom of the house, I just put it over Andrew's image, so you do have the horizon that's beyond it. So it's kind of a mixing of a metaphor, if you allow me that kind of artistic license.
Okay.
Okay, does that make sense?
Yep.
Okay, thanks. All right, so here's the next step where he's moving away 1 kilometer, but the result that you're going to see is the effect of the medium. Okay. So now we've got this same red roof house, but now we've got a slight inferior mirage. Okay, so let me go back. Here we can see the entire floor. This is the bottom floor. These are the doors that open up, and you can walk out and see the Chesapeake Bay and be thankful that you've got a Airbnb vacation rental and all that kind of stuff. But here, right here, that's the bottom floor, but the resolution is gone and we've got an inferior mirage. Okay. Yep. Here is a more severe one where you've got the water. Here's the limit of the water right here, and then the mirage begins, right? In this one, the mirage is higher up, and we can actually see the top of the house.
Oh, okay.
So the top of the house is right here. The top of the house is right here. But in this one, you can only see the bottom of the second floor, right? So here's the first floor. Here's the inverted image here, and it's lost in translation. Like you can even see here's this 2-story stairwell outside. Second floor down, and then down to the ground floor, and then it comes back out. So here's the second level. So the only thing we can see here at the very bottom of the mirage is the bottom of the second level. Well, in this image here, we've got a full view to the top of the house here. Okay, so here's this floor ceiling or roof, I'm sorry. Here's this roof here. Here it is here. Here's the top of the roof here. Here it is here. And then the next one, we've got the entire house, right? We can see the tree line. We can see the tree line above the house. You see how that intensity changes?
Yep.
So again, I'm not the one changing. The medium is changing the depth of how much of the mirage we see.
Now, so you have the water line then below that.
Right here.
And would you see that as the top of your proximal, what do you call it?
Proximate looming.
Proximate looming.
I think I could say yes, because the way that I came across my ability to, I suppose, start to label proximate looming. Let me go back. Let me see if I've got anything in here. Okay, can you see that okay?
Yep.
So I've got proximate looming here and sinking, because I think that those are possibly the same kind of effect. So this observation is 9 miles away. Okay, so 9 miles away from me. And you can see that I have tried to line up the channel marker on the right side of the frame.
Yeah, and that's good.
As much as I can. Now, these two images on the left and the middle are all the same focal length. It's 357. This one to the right is just a little bit under, it's 268. And that's because I usually try to get this cape. This is a cape right here. Okay. So this cape is about 6 miles away. And then the farther distant land is another 3 miles past that. Now, my point is, excuse me, there are times when I can fit that cape into these images here at 357, but today I couldn't. So I normally try to fit the channel marker and the cape into my field of view. And I can do that at this focal length. But for whatever reason, this day I couldn't. This day I couldn't. This day I had to zoom out a little bit to include the cape in, as well as the channel marker. So this is looming, which means that I'm seeing farther than I can when I normally have these images. So this image here in the middle, I would say is about 90% of what I normally see, right? I don't normally see full all the way down to the shoreline. And I can show you different footage here where you see this channel marker here, and it's got a light.
Yeah.
This channel marker is 500 meters from me. Okay, I know it's 500 meters because I flew my drone out, and my drone stopped right at the top, on top of this, and it was 500 meters. So I would just take that for granted. So I have video footage of the channel marker on the other side of the bay blinking. So let's take it for granted that that channel marker is 500 meters away from the shoreline. I feel comfortable saying I'm looking shore to shore right here. Does that make sense? Okay. Yeah. So here we've got this little niche in the tree line that I've circled. And I've gone over here and I've circled it again. But if we drop down, we don't see any of the houses.
Okay.
Okay. And if you look at the texture of the water, it's immense.
Yeah.
As opposed to over here, look how tiny and small and distant these ripples look. Look how massive these ripples are here. Now, I would say it's more than likely that these are all the same height, but the medium is magnifying the water.
Yeah.
And
so you've got
go ahead.
Light going over cool water with warmer air above it, so that the light from that part of the water is being bent downward, so that from at your eye, you see it as higher. That's the way I'm kind of interpreting the effects of proximate looming.
Okay, so how would you differentiate that from the left image? How would you describe that?
Well, I'm just comparing the middle one to the left one, and then
Okay.
the middle one, it looks like you had more bending of the light, and that would have to mean more temperature change, and that the light that's maybe heading upward from the water here is experiencing a greater temperature change. It's going from cooler to warmer, and then that bends it down as it comes to your eye, and that gives you a higher perspective of where the actual level is. That's the way I see looming.
Okay, so that deals with our proximity, so to speak, but we have a combination of effects, and that is that we have a looming of the proximate water, and then an inferior mirage behind it.
Yep.
So we have two different effects happening to a certain extent because, well,
Well,
so
you're
you,
seeing, they're both refraction, but refraction from different temperature profile environments.
yeah. So let's, even this one on the far right, this one's the more extreme because, well, I guess I can't say that. I can't say that because it's not the same focal length. I guess what I need to do is go back, if I can go back and find this day and see if I go into a 357, because I would want to actually put the 357 up. But you can clearly see, if I'm correct, right? You see this little niche right here?
Yeah.
If I'm correct that that's this niche and that's this niche, the shoreline is grossly compressed,
Yes.
as opposed to this one that the shoreline is actually magnified because we can actually see the houses and possibly the dock. This is closer to the water, so that could very well be a boathouse or something close to the shoreline. So if we just had, yeah, I guess here's the thing that I wanted to say, I guess to a certain extent, to what we were talking about before with the web page. If we're looking shore to shore here on the left, if we're looking shore to shore, and I can say that, let's say for instance, I had a friend here on the dock, and he had a flashlight or a laser, and he would flash me, and I could see that beam hit me. What I would like to suggest to you is that if he had a strong enough beam, I would see that beam of light right here where the arrow is, right where my cursor is, because that's where the shoreline is, up here.
Okay. Okay. So in this case, the shoreline is not really visible like it is on the left, right?
Correct. So you've got these little white dots here, which very well could be this house, and another house, right?
Mm-hmm.
So we see a strong inferior mirage that is turning this house into a smudge. But if you cut that house in half with the vanishing line or the fold line, then what you understand is beneath that fold line is the land that's right there.
Right.
So I think that that's a little bit of what we were talking about with your image here. You see this okay?
Yep. So I'm thinking
So
I can bring the water up, I can bring it up at least to the top of my little trees that are pointing downward. And I could just make that a straight line, and that would improve it because you're showing a little bit of the water. Yeah, of course.
so I think what you could possibly do is somehow try to find out, because right here you've got let's see. So this bottom image is showing you the mirage.
It's
Right?
showing the mirage of the island, but not the mirage of the air.
Of
And
the
that's
sky.
what you pointed out. And
Right.
so I added
So
that air in there, but a little too much of it.
right. Yeah. So I guess the way to do it is you want to keep the mirage with the water, like you've got that tint there, and then just find a way of bringing the sky into this somehow. But
Yeah.
um,
Yeah.
so if you look over here just real quick, this is the farthest observation that I have on the Chesapeake Bay. Oops. This is an observation that's 12 miles away, and you can see over here to the left and to the right that there is an inferior mirage with, it's a very acute inferior mirage. But on the lower image here, you have the sky that is completely miraged beneath the image. So you've got this tree right here on the top right is right here. That one right there. Okay. So then you have, so I guess what I'm trying to say is that you're still looking at this entire physical landscape in front of you. It's just that you can't see it. So if there were a farmer on this grass here with his tractor, that farmer would be right here on his tractor on the grass. But because of the intensity of the mirage, you can't see him. But it's also changed the entire dimension of this field of view. So even though you can, I guess what I would suggest is that you would almost have to show that with this mirage, the angular size of this landscape would have to also change. I don't know what you would say that it is, but in the sense that this landscape here wouldn't match this landscape down here if we did a blink test. Do you know what I mean?
Yeah.
So to me, this is just a kaleidoscopic dance that the medium is putting on for us. The medium does whatever she wants.
Yeah, but it has only one handle, as I see it. It has only the handle of temperature profile, because the density of the air, the amount of moisture in the air could have a little bit of effect.
So in your opinion, what percentage of influence would you say that the temperature has?
Well, I think the temperature is the origin of all the refraction phenomenon, because the density does not appear to, the amount of moisture in the air has a little effect, but I don't know how to characterize it. But if we assume it doesn't, I don't know. The effects on the index refraction are extremely small, and the moisture in the air does affect it a little bit. And I'm saying that based on a NIST table I looked at.
Okay.
And I did add a link to it. And it had a table of just the index for refraction as a function of temperature and also of relative humidity.
Mm-hmm. So so what about air? So okay, if I guess the three things that come to my mind are temperature, humidity, and air pressure. I mean, I bought a little gauge that had both temperature and barometric pressure and humidity. RH is RH relative humidity, right? That's what RH stands for, relative humidity.
Yeah.
So to me, I don't know how to quantify those three, if it's 33% across, if it's 60, 20, 20, I don't know.
Well,
I don't know.
I'm certainly getting the impression from what I read is that the barometric pressure is not particularly a variable on the speed of light. It is on the speed of sound. But the indications were that although the relative humidity can change it slightly, it is mainly the air temperature that affects the index of refraction. And the refraction phenomena has to depend on that index of refraction as its main variable, as I see it.
What I'm going to do real quick is oh, that's not the one I want. I want to bring up something that I mentioned before with this and see if this can take us a particular direction. And feel free, if you think of something or if you need to go, just let me know. I don't want to take up more of your time, but although I could talk about this forever. So whatever you're able to give me, I appreciate. But if you feel like something needs to be said, feel free to interject. So the one thing that has impressed me in my observations that I don't think has been thought about, and if it has, I just haven't come across it. But if we look at this image here, okay, so let me say it this way. If you remember what I've said about my own observations, in these diagrams that Andrew Thomas Young has worked on, he is the variable. He's kept all the conditions the same, and he's simply moved his distance. Okay.
Yeah.
So the way that I'm going to approach my thought to you is that I'm not the variable because I've been stationary. My camera's set up in the same way. So if I'm looking at the same observation, right? If I go out on Monday and this is the observation I see, and then this is the observation that I see on Friday, I'm gonna lay this over to a certain extent. Okay.
Yeah.
So what that means is that the horizon here that you can see on the image that I'm stretching right here, do you see how there's a difference between this horizon and the horizon behind it?
Mm-hmm.
This horizon here is created by the mirage. So that behind this mirage is the true depth of field. So just like there I see the full image, here I don't see this corner, but that doesn't mean that it's not physically still there. Right?
Right.
So that's what I would like to suggest is the same thing for Andrew Thomas Young, that even though he's moving himself farther back, and farther back, let me see if I can think about this. How am I going to do this? Close this. Let me try to think of how I was going to show you this. Open this one. Oh, that's not, I can't do that. I don't think this is going to be. So Andrew Thomas Young is moving farther and farther back, and he's got this image here. But what we need to understand is that this is the physical reality, right?
Mm-hmm.
So even though the physical reality isn't down here, it's up here. Do you see what I'm doing?
Yeah.
So
that means you're seeing a refraction of the entire water surface then.
correct. And the original water level is up here, but you can't see it. Because if you remember the first image, the horizon was behind the target. So in this target here, this is a false horizon. The true horizon is up here.
Okay.
To me, that's something that I've thought through. And I could be wrong. I could be 100% wrong. But that only makes sense for me because in these images that I can produce, right? Here's the false horizon. Right?
Right.
That's created by the mirage right here. Because if we could wipe this away, if we could wipe away this refractive index, we could see down to the shoreline right here. We would see down to the shoreline. And as a matter of fact, I have a shot where in looming conditions, I can see the water above this cape. You know, like around the corner, I can see water higher than the cape. However, that's very far and few. That's very far and few between. So I'm very, very happy to have made contact with you because I've wanted to talk with someone about this for quite some time. Let me just bring this up. I worked on this today a little bit. This is that same house.
Mm-hmm.
These are all the same focal lengths, and hopefully you can understand that this is not a result of my not knowing how to focus my camera.
Right.
Okay. Yeah. That's the medium that's messing with me. But what I've done is I've lined up the top of this tower. This is another helpful marker for me, that I try to line up this tower in the left-hand corner to take this photograph. That way I can always have that control, right? Yep. Okay. Yep. So as I move from this one over to this one, these are all the same focal length. Okay. So in this one here, we can actually see, let me do this real quick. You see this where the arrow's pointing?
Mm-hmm.
That's the boat dock, where the dock gets taken out at the ramp. So I've actually driven across to the other side of where I take these photographs, and I've stood right in front of this pavilion on the water. So I feel very comfortable saying that this is a line of sight from shore to shore. Okay.
Okay.
So we've got this this retaining wall. Got a retaining wall all the way across. Retaining wall right here. This space is for the boat ramp, and this is a boat dock. So in this image, we can see the pavilion, right? We can see the pavilion, but we can't, I mean, I guess you could probably say that that's the boat dock, but it's not as distinguishable. And then you can't really see the rocks. Here you can clearly see that you can see, yeah, I can see rocks.
Yeah.
I can see, right? But here, no. And then here, even less so. And then on the far right now, we have an inferior mirage. So now we've got the water level here, but here we can't see that far in the x-axis, right? The x-axis going across into the distance, right? The water level stops right here. So let's just say that it's, let's just say for argument's sake, that water level is right here. So then my question would be, what's this distance here? What's that distance? Right? Because that distance then is right here. So the mirage is, this is my thesis. The mirage is not a vertical image because it's covering physical distance. If I could put a boat on this location here, got this boat right here, I would know how far this boat was away from me, right? A GPS will tell me it's 3.5 miles away from you. So if I knew where this apparent horizon was, because I could put my friend in a boat, and once he got there and I said, okay, Joe, stop, stop, you're right there. You go any farther, you're going to get into the event. I want you to stop. He stops right here. And I say, what are your coordinates? He says this. And I say, okay, you're 3.5 miles away from me. Then that means that there's 2 miles of distance from this water line to the house. And so then that's why I've come to start to talk this way and say that this mirage, even though it appears to be a vertical image, it's not.
Oh, I'm beginning to see what you mean by that now, that this position is actually not close to the shoreline. It's at some other point. You're seeing almost a peak of your proximate looming.
Right, right. Yeah, yeah. Yeah, that's exactly right. Right. Yep. Yeah.
Okay. Those are very interesting images, and that I've seen your the actual mirage a lot clearer with these images than others that you've sent. So that's really neat. And just the fact of your experimental technique of having standard locations and standard focal length and stuff allows you to do real science there because you're controlling those variables.
Yeah, I think the only thing that I would want to try to do if I could after this would be to get a few more of me to go out into the event to do measurements and like you said, if you think that the profile, if you think the profile is uniform across the corridor, I understand assuming a uniform profile. But for me, I would want to take those measurements all along the way just to know for sure.
Mhm.
You know?
Yeah, I was just visualizing some kind of pole with thermometers at different distances.
Is there anything else that you thought of before that you want to bring up?
No, I got enough to think about. I'll go
Yeah.
read. I'm gonna go read some more with Young, make sure I can
Okay.
understand him better.
Okay, great.
Uh,
Well, you know what? Great. I appreciate that. So it if you can see anything that he has said that would help me look at what I'm suggesting in a different way, I would appreciate it because I've looked over his stuff many, many times and I have not seen him address the things that I'm trying to suggest. So if you see that he has actually addressed some of these things, please feel free to let me, know that you found this, this reference or that reference or whatever. I'd appreciate it.
okay, I would appreciate continuing the conversation.
Well, good,
I
good.
appreciate that being shared with the experiments because that's the way we learn science is really experiments. And the kind of controls you've put on it has put you in a position to actually do real science there. And measuring the temperature profile itself sounds like a pretty daunting task.
Well, let me ask you this question real quick before we go, if I may. You've heard me make the suggestion that the image of the mirage is not stretched vertically, but it is a horizontal.
Or
How would you suggest I go about trying to quantify that? What would that look like?
well, the kind of suggestion that you made is to position an observer at so that you see them at that peak location of the water with the GPS. That would be one way, like you're saying.
Yeah. Okay.
That to show that line that you're seeing is not at the shoreline, but it's somewhere out in the open water.
Okay. Yeah. Right.
I still puzzled about what Greener did with those profiles that that he went from the temperature the profiles of the ray paths, and then to get that particular picture of the three images of the sailing ship, I can see the correlation, but I couldn't have gone from his curves to that. I wouldn't know what the path would be to go from his top curves to that bottom thing. It's just like he dreamed up something that would actually give him that. So it's like a forced fit.
I think I understand what you're saying, and sometimes I feel like when I'm looking at either Andrew Thomas Young or Greenler, or I think even on the GSU site, when I see these ray diagrams, I often say, I show me that in a real photograph, or show me, like, I guess what I would say is, like, if I showed Greenler a picture that I have of the red roof house in an inferior Mirage, and I say, okay, diagram that for me, because then I would have a real event to then hold up and say, okay, where do you see this ray? Where do you see that ray?
Yeah.
So, all right, Rod. Well, you take care and stay safe. Okay.
Enjoyed it very much.
All right. I did
I'll
too.
be in touch.
Okay. Thanks so much.
All right. Bye.
Bye.